Good evening and welcome to Boston University. Thank you for being here. I want to start with a number. That number is 8. Just 8, because a few months ago, in her first presidential address, President Melissa Gilliam stood up and named 8 convergent themes, 8 areas where this university is making a deliberate bet on the future. Healthcare across lifespan, global sustainability, urban resilience, the arts and the human condition, infection and immunity, AI and computing, the well-being of children, social and economic opportunity. 8 bets. And what struck me most wasn't the list, it was the framing. She called Convergence BU's North Star, a fixed point to steer through, as she put it, choppy waters and unfamiliar terrain. You see, convergence can sound a little bit like an academic buzzword. So let me tell you what it actually means and why it matters in this room today. The hard truth is that none of society's grand challenges, not one of them, respects the boundary lines of a single discipline. Brain health doesn't, drug development doesn't, energy, healthy aging, the function of our cities, none of them sit neatly inside one little department, one school, one field. They never have. We just used to pretend that they did. Convergence is the decision to stop pretending. It's not interdisciplinary work as a side project, a center here, a joint seminar there. It's something much more demanding. It's the intentional synthesis of expertise across fields to produce solutions that simply could not have emerged any other way. Ideas that don't exist until a biologist and a computer scientist and an engineer are genuinely building together, not just sharing a conversation in a hallway. And this is why a university is the place that it has to happen. You see, universities do the basic and early applied research that everything else is eventually built on. And a university, this university, already has every relevant discipline under one roof. The talent is here. The question has only ever been whether we'd lower the walls between them. BU has decided to lower those walls. President Gilliam said something I keep coming back to. At BU, convergence is everywhere. In the sciences, yes, but also in the arts and the humanities, in how we teach undergraduates, in how we train the next generation of researchers, lawyers, doctors, engineers, past, present, and future. That's not a slogan handed down from an office. It's a commitment that has to be lived at every level, chairs, deans, our provost, and most importantly, by the faculty actually doing the work. Which brings me to the people that you're about to hear from. This panel is Convergence Made Real. You'll hear from researchers who are not theorizing about breaking down barriers, they're doing it every day to take on some of the most consequential challenges we face. They're going to show you the wow, the breakthroughs, the methods, the results that exist only because disciplines come together. And they're going to be honest about how hard it is to build a culture that makes that possible. My name is Costa Ligris. I advise senior leadership here at BU on innovation and entrepreneurship. But today, my job up here is fairly simple, and it's nearly done. My job is to now get out of the way. To guide us through this conversation, I can't think of a better person. He helped lead the very task force that identified those 8 themes that I mentioned earlier. He's been at the center of BU's convergence strategy from the start, and he understands both science and institutional courage that it takes to pull it off. Please join me in welcoming our moderator, our vice president and associate provost for research, and my friend, Ken Luchin. Thank you.
Is my mic on? Yes. Okay. Thank you, Costa. I'm sorry my back was to you the entire time you were speaking. This session is not just examples of how convergence is leading to innovative breakthroughs for society, but it's about how strategy, culture, structure, and processes of higher education can embrace convergence across its entire philosophy and way of functioning. And so I'm going to be a little redundant with what Costa said. I want to affirm again that if you were asked to come up with 5, 10 of society's grand challenges, whether it be brain health, whether it be healthy aging, or the energy needs while sustaining the economy, or urban function and resilience at a complicated time, I imagine almost everyone you came up with will not be one that could be solved by a bunch of brilliant people, all from the same discipline. So that drives this concept of convergence that Costa was talking about. It's a radical form of interdisciplinarity, where you get everybody in the room at the beginning of trying to solve the problem from all the disciplines that have to be relevant to the problem, and they end up coming up with the most creative, high impactful solution. Sometimes synthesizing new methods that never existed before they started talking. An example, synthetic biology, programming cells as if they're engineered systems. That field was created here at Boston University. Now, universities, as was said, are the place that's most responsible for the basic and applied innovation and research and discoveries that lead to those transformational approaches to address societal challenges. And as was mentioned, the universities are pretty much the only kind of organization I can think of, particularly at the Research One universities in this country, that have all the disciplines inside the organization itself. Now, if you ask universities, do they support and engage interdisciplinary research, maybe even convergent research, they'll tell you, yes, we have interdisciplinary research centers. And that's great, except for a couple of things. Interdisciplinary research centers do not control faculty hiring. They don't control PhD recruitment. The directors of those centers, if they're university-wide, don't report to the chairs of departments or even the deans, who do control those things that are the very resources you need to do convergence. So it compartmentalizes it in these units, and even the question is, how do you make the research centers interact with each other? For universities to succeed at this culturally across the whole institution, they have to, as was mentioned, radically lower the boundaries of disciplines, but they also have to stand up new processes for intentionally hiring faculty to support convergence. They have to figure out new ways to develop mentoring, particularly for junior faculty, where collaboration is the goal, not something to be avoided. And they have to get buy-in from the leadership, from the chairs, from the deans, from the provost. And BU has done this, and they've built a whole new strategic plan around convergence along 8 convergent themes. So today we're going to hear from panelists who have advanced this transformational approach. Our first panelist we'll hear from is the Dean of Engineering, Elise Morgan, who will give you a sense of how the College of Engineering has embraced this concept and deployed it to actually elevate the impact of engineering research to society at large. Our next 3 panelists will talk about transformational innovations and discoveries and technologies and approaches they're taking for society's challenges. Nahid Badilia is the director of the Center for Emerging Infectious Diseases, and she will talk about an incredible innovation that is so relevant yet again, unfortunately now, about surveillance and managing of emerging infectious diseases, where she had to cross disciplines not only within her center, but to other centers. Likewise, Mark Grindstaff is the director of our BU Nano Innovation Center, a world expert in nanomedicine and nanotechnology, and we'll talk about a breakthrough he and his colleagues have done for addressing a new technology for vaccines and other diseases by integrating with another research center. Aisha Koskin is the director of the Center for Information and Systems Engineering, and we'll talk about transformational approaches to address the energy demands of data centers, interacting with both other research centers and our Faculty of Computing and Data Sciences, built intentionally to integrate across disciplines. We'll hear about a nonprofit breakthrough because of this approach, and from Mark and Aisha about startups that emerged from this approach. So with that, I will turn to Elise, and the floor is yours.
Thank you, Ken. And yeah, it's great to see everyone here. Good evening, and I'm delighted to be with you. I think if you take away one thing from tonight, or at least my remarks, it's that culture really matters. And culture is what makes our mission possible at BU, and I can speak specifically about the College of Engineering. So the mission of the College of Engineering at Boston University is to expand the power of engineering to transform lives at scale. By at scale, we mean thousands, hundreds of thousands, millions of people. We think about technologies like pacemakers, hearing aids, wireless communication, high-speed transit. So these are engineering successes that have revolutionized the quality of life, longevity of life, the connectivity of people to each other, to their friends, to their families. And so that's really the superpower of engineering, I feel. And it also, even though I described those technologies as engineering successes, they weren't built just by engineers, right? They didn't come to fruition only through engineering. It was really a combination of disciplines. Now, the culture in BU engineering is extraordinarily collaborative. I think that's not localized just to the college. I think it's true of BU in general. It's collaborative and it's collegial. I like to say that we're a lot more focused on impact than we are on our own ego. And what that means is that we're very good at working together. We're very interested in making a collective impact. And so I think it's not an accident that fields like synthetic biology that Ken mentioned were born at BU. Another one, neurophotonics, combining manipulation of light through engineering technologies to make advances in brain health. That's another field that was born at BU. That was not an accident because of the culture that we have of working together. And so what we have done is really take that baseline culture of collaboration and collegiality and make an intentional ramp up of it to really attack convergence and say, well, culture is really important, but you also have to feed that. You have to nurture it and you have to expand that. And so how can we do that in ways that break through the traditional ways that academia, that universities would function, so that we can really achieve this higher level functioning that is convergence? And so one norm in universities, particularly for faculty doing research, was sort of this single investigator, be the best in your field, be the best in one particular area of your field. Maybe even publish some papers where you're the only author. That's really antithetical to convergence, where we really need people working across disciplines and often working together. And so we started to do things like revising how we evaluate and promote and celebrate faculty achievements so that our faculty are free to pursue convergent research rather than having to stick to these outdated, frankly, norms at university promotion guidelines for faculty. And we started doing faculty hiring college-wide, meaning that we're running, say, a search in energy and sustainability that has participation from all of our departments, because you could be working on biofuels as a biomedical engineer. You could be working on better battery technology as a mechanical engineer. You could be working on more efficient computing resources as a computer engineer. And so we said, well, if we want to make an impact in energy and sustainability, we don't want to choose among those areas. We want someone who will come and synergize with our many different facets of work in energy and sustainability. And that meant working together to hire the best faculty, by asking not just who's the best biomedical engineer, but who is the best shot at advancing, the next generation of vaccines, who's the best chance of, advancing how we understand brain health. And so we've done these convergent faculty hires that really have been a magnet for really sort of fearless intellectuals that are really top young scholars to come to BU and be free to do the kind of work that they want to do across disciplines rather than being pigeonholed. And so I think looking forward, I would describe our strengths are really at the intersection of computing and health and engineering. And I see enormous possibilities for preventing the next pandemic, right? Better vaccines, right? More efficient computing, intersection of AI with drug discovery and development. There's just a really rich space at that intersection, and I think that's one area that we are headed in.
Thank you, Elise. Next, I'll call on Nahid to give us a summary of the kind of exciting work and really important work, perhaps more than we might have thought again, in emerging infectious diseases that you're leading.
Thanks so much, Ken. So as I sit here, I don't need to convince you that we live in an age of epidemics. Just as we're getting over the global crisis that occurred through an Antarctica cruise that may have now carried an entire cluster of Andes hantavirus outbreak, we're coming out of that, and we have a large regional outbreak of a new Ebola species that we don't have that much experience in. We live in an age of epidemics. And what my center does, the BU Center on Emerging Infectious Diseases, is policy, public health, and data science research related to how we respond with evidence-based to these emergencies. How do we prepare in a way that makes sense? How do we use resources the right way? To give you a sense, right now we're doing a study to help public health responders think about how many diagnostics are needed for the Ebola tests right now in DRC. So this is the type of work that we do. One of the central issues in my field is before you can respond to an outbreak, you need to know about it. There needs to be a surveillance system that lets the global community know, like the Paul Revere, if you will. The outbreaks are coming, right? Everybody needs to know at the same time so you can all prepare. What's lacking in our field is that a lot of times formal surveillance, which is done by governments, lags behind. It comes from healthcare workers taking care of patients, reporting up, that goes to formal public health systems, and all of that delays potential signals that would have been important had we known about it earlier. There is an idea called informal event-based surveillance that allows you to circumvent that by looking at information that's coming from media, that's coming from people in the field, that's coming from public health partners, and it lets people think about how preparedness should start before the formal surveillance kicks in. So what we noticed was that every available service that was doing this type of event-based surveillance and integrating new technologies was behind a paywall. We wanted to create something that was free. And we wanted to be able to digest a whole amount of information, make sense of it, and be able to then use expertise within our center and across the world from public health experts to be able to share that with the rest of the world. So we worked with the Hariri Institute for Computing and Data Sciences, as well as with John Brownstein's group at Boston Children's that does digital epidemiology, web scraping, to create something called Biothreats Emergence Analysis and Communications Network, Beacon. You can check it out on your phone, beaconbio.org. It's like a social media feed if you enjoy figuring out where the outbreaks are every single day. So what was amazing about what we did was we were able to take the expertise here at BU from the large language models that that our partner, Yanis Pascalidis, Professor Pascalidis, was able to work with us to help develop, go back and forth or iteratively train, which can then allow us to extract key information from all these different types of data sources we were getting, help us think about the credibility of the news sources we were looking at, and then as we made editorial choices about what we thought was important, what needed to be reported, we could then shove that information into a draft report that could be used to then edit. So that's what the LLM does for us. And then we then edit all that, add our expertise into it, and we share it publicly. So why does that make a difference? Boy, it's a lot of information out there. By being able to use a large language model that's trained specifically on infectious diseases, it allows us to have a starting place. That means we can then add our own context. The reports that we make help people understand not just that something is going on, but why it's important and whether you need to care about it. What's the risk to you? That interdisciplinary partnership allowed us to move the things that humans didn't want to do into a space where then we could concentrate on all that context that matters. So what's the wow factor, Ken? In 1 year, so by the way, the other thing that made it possible is that BU provided the pilot funds to help stand up Biothreats Emergence Analysis and Communications Network. It really, the wow really is that this university has made the impact I'm about to tell you. In 1 year, we have users in over 200 countries and territories around the world. Our reports are integrated into WHO's Epidemic Intelligence and Open Sources from Open Sources surveillance platform that over 120 governments and public health organizations use. We have been cited by media, cited in public health both academic publications as well as public health reports. Organizations use us to help guide their responses. For example, Coalition for Epidemic Preparedness and Innovation used our information about Rift Valley fever outbreak in Senegal to help analyze whether they should deploy their vaccines that were experimental in that outbreak. So the best thing for me is that every type of person uses it. I hear from clinicians who use it in the emergency room. I sometimes hear from citizens who talk about whether they need to worry about it in their own communities. And people are democratically also putting the information back in. They use our website to send in reports. The meningitis cluster in the United Kingdom, we first heard about it from someone who lives in Kent who wanted to let us know, this is not on national media, can you put it out? So that's the wow.
Thank you, Nahid. That was great. So that's interesting. There's a center at the intersection of the biology of infectious disease and computing, and all the public policy in the middle. So we have two other speakers today. Talks about the computing aspects, different centers altogether, and the biology of infectious disease. So I'll start with Aisha to talk about the computing challenge you've been facing and the world's been facing.
Thank you, Ken. So I'm a professor here. I direct a research center, as Ken mentioned, and I'm also the chief scientist at a startup called Emerald AI. My research journey here has been Convergent from the beginning. Now looking back, before convergence became a buzzword, as Costa was mentioning. It's because I'm a computer engineer and a systems researcher, but I quickly realized that the problems I wanted to work on, the difficult problems, don't necessarily respect disciplinary boundaries. So specifically, I'm going to talk about data centers today. So data centers are in the news a lot. You must have seen something about it, right? So over a decade ago, this started for me by asking a question that seemed a bit strange at the time. Like, can data centers consume power, electricity, in a way that matches what the power grid needs? Essentially, it was a very interdisciplinary topic from the beginning, looking into energy problem, computing problem, power systems problem together. Now, normally what happens is a data center comes in and says that I want this much power capacity, and then it can consume whenever it wants, however much it wants within that boundary, and the grid, power grid, all this, power generation, transmission networks and all, need to figure it out somehow. And this approach mostly worked, until recently when AI started taking over the world. So what's not working right now is that the power demand is enormous. We are talking about hundreds of megawatts scale data centers reaching gigawatts soon. And power grid is public infrastructure. It's costly to build new generation, new transmission. It takes years. But data centers want their power now. So we have this collision of essentially two big infrastructures. One is the power infrastructure, one is the data infrastructure. So for us, this started, like I was saying, with a question that evolved later into experimentation, building prototypes and all with a very interdisciplinary team from the starting point. And this is an interesting journey because it's not also trivial to bring a computer engineer and show something about power systems. Typically, they would walk away in most cases. But these collusions essentially also started to spark some ideas. For instance, I'll give one example in my journey. We found early on that computing has a lot of flexibility that other physical systems don't. When I'm accessing some AI model or any app on my phone, I don't really care where that computing happens. So computing can move. I don't really care if the data center is right there or in New York or in Atlanta, etc. Whereas if I want to turn on lights in my home, I can't really move that to Ken's home. Or you can't easily move it across time either. So for instance, like if there's a hot summer day, I'm at home in the evening, I want to turn on my lights. I probably don't want to sit in the dark and then turn on my lights at like 11 p.m. or something like that, right? So whereas computing, a lot of computing is flexible. It can wait. It can be delayed at times, while the users don't even notice it for a lot of applications. So Emerald AI builds on these principles, commercial grade software for data centers to become flexible in their power, so that when the power grid needs more power, data centers can be nice citizens and reduce their power temporarily while watching for the performance or service agreements that are running on the data center. And this took a lot of time to get to this point. Essentially, when we started working on this research more than 10 years ago, there was no market for it. I was lucky to find colleagues and students who are passionate and interested to make dance at this interesting interdisciplinary problem together. And when we first started writing papers about this, there was nobody really thinking about this in the same way, except for this one other professor in Caltech who saw my paper and invited me immediately. So it was just a few of us thinking about these things. And as, again, former speakers mentioned, the universities are breeding grounds for this kind of convergent research because there's a lot of fundamental research that needs to be done before ideas mature, before markets appear even, and before industry, there's a role for industry to build it further and market it and sell it. So this all happened here, started with ideas, simulations, prototypes, and now we are building a startup with partners, big company partners like NVIDIA and others, with also collaborations with national labs and nonprofits and all. So convergence, I should say, in this line of work, like energy, like AI, it also connects to climate and sustainability, is not a luxury item. It's an essential piece. When we say AI, AI is no longer something about just computer science. Energy is not just about physics or mechanical engineering or electrical engineering. I already mentioned 3 disciplines to say energy, but it's even beyond that. Climate is not just about earth and environment science. So this is all about technology, society, infrastructure, policy, all of these colliding. And the best ideas to solve the most difficult problems come out in this way. So thank you. And BU has enabled this line of research, thankfully, so that we can now go do impact. But I really think we are at the beginning of what's possible.
Thank you, Isa. Okay, so now we're going to flip to the bio side and talk about an infectious disease and so forth. And Mark will give us a sense of how he's deployed Convergence, again, across his own center and others.
Thank you, Ken. Well, good evening. It's wonderful to be here. And I can tell you I love basic research, but I also like doing translation. If we can take those ideas and discoveries and move them out into the real world, it's an amazing accomplishment. And I've been very fortunate with my students and myself to actually get 4 products out. We have an anti-cancer drug to help millions of people. We have a sealant for the dura, so if you have a glioblastoma procedure, for example, spine. And most recently, we developed a marker for diagnosing breast cancer. And key to all of those types of successes is convergence. And that means you have a research program where you have people from different disciplines, different areas of study. You have different technologies. You have different ways of thinking about the problem. And all that comes together to try to go forward with an idea or a hypothesis to go after. And I'm going to tell you a short story about messenger RNA. And we're all very familiar with messenger RNA because of our COVID vaccine. It's a single strand of RNA. It has 3 components to it. On one side, it's called the 5' UTR, untranslated region. Then in the middle is the part that encodes for a protein. And then on the other side is the 3' UTR. And for the COVID vaccine, what they did is in that codon region, they put the spike proteins. In other words, the protein that's on the virus that your body's going to, quote, recognize. And they turned it into a lipid nanoparticle. They injected it intramuscularly. And then once it got there, that messenger RNA translated. It took that code, created a protein, and exposed your body to that protein. And now your body, its immune system, recognized that protein and developed an immune response to it. That way, when you got infected, you had less of a response. Amazing technology. Pretty remarkable from the idea all the way to the conception. However, if you look closely, you actually got a fairly large dose. It wasn't a small dose, it was a large dose. And the reason is it expresses for a fairly short period of time and not very much. So we give you a lot. Well, there are other technologies out there that are actually a little bit better, but we don't use them. And one of them is called self-amplifying. So it's the same strand of messenger RNA, but in front of the protein cargo area, it encodes for an enzyme that makes more protein. So at the end of the day, you inject it, it makes more protein. That means you can give a smaller dose, which is safer. It'll go for a longer time period. Really cool. It doesn't work very well. It's so big, cells recognize it and destroy it. And people have known that for like 25 years. Have an amazing graduate student come into the lab, really interested in messenger RNA. We start talking. He goes, what about self-amplifying RNA? I said, it just doesn't work. And so he starts understanding it, working in the lab. And for messenger RNA, what was critical is 2 scientists made this Nobel Prize-winning discovery where they put a different nucleotide, one of the pieces of this RNA strand, into the structure, and that basically cloaked it from the immune system so it worked. And that's what's in your product. That's what's in the vaccine product. It doesn't work for self-amplifying RNA. Well, he went into the lab and actually found a way to cloak that piece of RNA that's now self-amplifying RNA. So now it doesn't get degraded quickly when it goes into your cell. And so what Josh was able to do was, for example, make a low-dose vaccine. So take something that's 1/100th the dose of Moderna's vaccine or Pfizer's vaccine and get the same outcome. Or make a cancer drug that will actually take it to the cancer, only express in the cancer and not in your liver and spleen. So by coding in particular pieces of that structure to only be recognized in certain cell types, we now have the ability to actually tell it where to function, which is super cool. So that's led to a company called Helicon, brand new company, and it's actually making a low dose tetraflu vaccine. So a 1/100th the dose of a current vaccine protects you against all 4 forms of flu vaccine. How long did it take us to make it? A month. Impressive, really cool, really fast. If there's an outbreak, we can think about how to respond to that. At the same time, we've made structures that will go to tumor cells and are effective and reduce the tumor. Now that project's gone off. At the same time, it created an amazing environment here. Now there's about 20 people working on this project. There are people from infectious disease, people from biochemistry, people from pharmacology, people from mechanical engineering, people from biomedical engineering and chemistry. And all those faculty and all those students come together and we meet and we talk about this whole new area of science. And so Convergence was key to that. So BU is a wonderful place to be and we can do these amazing things. And I'm very grateful to be here and to be able to do that. So with that,
Great.
pass it back.
Thank you, Mark. Thank you. So I don't know if there's a QR code anywhere where you can enter questions. Do they have it? Yeah. Okay. So we don't have any questions yet. I'm sure momentarily we'll get hundreds. But just in case we don't get hundreds, I have a few questions we can ask the panel. So I'll start with a question which is not one of the questions that I prepared in advance, but that I thought of as you were all speaking. You all, or at least the 3 innovation faculty of the centers, you all are directing Convergent cross-disciplinary centers, and yet in this new initiative, this new transformational approach, you reached out to another interdisciplinary center, Biological Design Center, Hariri and the Computing and Data Science. What made you think that you needed to actually go amplify this whole concept of convergence to look outside your centers when you already had an interdisciplinary center? So I'll start with Nahid.
I think one of the reasons why is because some of the other organizations that are doing event-based surveillance have struggled with how to manage the time of humans on their teams and with the amount of information that's on there. And what we saw was, as I think Elise just said, AI is not a field for computer scientists only now, right? It is in our lives. It is a workflow. It is a methodology that we're going to apply to everything. And we said, wouldn't it be amazing if we can solve this problem of at least being able to get the initial extraction, the initial analysis, the initial draft report, take some of that work and use the power of large language models. So we actually had Yannis and I had a National Science Foundation grant that was looking at predictive intelligence, and we wanted to see if we could get these large language models and push them as much as we could to actually make some preliminary risk assessments as well. So that's what made us sort of approach this problem together about how we apply it to a public-facing portal that would help people sort of, think about these diseases. And it's really helped because what I didn't say was that in the short period of time, we've published over 2,000 reports on nearly 800 outbreaks around the world. And we would not have been able to do that without a large language model being able to translate any source that we put into it. Some of the difficulties have been, as amazing as large language models are, they can't do what humans can do, which is like pick up the phone and say, is this outbreak really going on, right? They can't verify. Humans still have to do that. The expertise is evolving, and humans experts are going to be ahead, particularly in emerging infectious diseases. So contextualization still requires humans, not just because of their expertise, but you do not want large language models to make predictions that you make public directly because there are geopolitical things at stake. So a human is always going to be the last decision maker in that flow. But what we found is that the integration, the working with another center, allowed us to expand our own thinking about where else large language models could be applied. And it's really grown how we might apply to other use cases within our center.
Great. That's a great example of what happens when you build the computing and AI and data science aspects of research not in a siloed fashion, but as an integral part of all disciplines. The boundaries to go across and look for that as this, simply they don't exist. Mark, how would you say you reached out to the biological designs, synthetic biology,
Yeah.
which was not part of BU Nano?
No,
Right.
no, not at all. And I think that's because the challenges are so complex, right? And having people with different expertise is key. And so knowing about biodesign, thinking about synthetic biology, and at the same time thinking about virology. And how do you integrate all of that to understand how a virus works? How can you take that understanding and then apply it to a real problem? So it's incredibly important to have those interactions. And it's face-to-face, it's in a room, all of that is key to going forward and being successful.
This topic of data centers and power grid interface, actually, for me, I was a junior assistant professor here, and this started through SAIS, the center I currently direct. At that point, obviously, I wasn't the director. I was a member. And then there was a visiting industry speaker who I know and respect, and he's also a computer engineering, and at the time he was working on applying computing methods to other disciplines, so he was interested in this. And then when he came, he told me, as a computer engineer and a person understands automation, there are some interesting things in the power grid space for you. So he wasn't thinking of what I ended up doing, but that put me in the same room with another person from SAIS, who is a power systems expert, to start, colliding on these, different problems. Like, what do I know about power grid at that point? Nothing. And what did they know about computing? Probably nothing. So we started there. Now, fast forward after some research, even a center may not be sufficient to do the research, because centers are, SAIS is a Convergent center. We have over 50 faculty members. We are themed about intelligent systems, which by definition is very interdisciplinary. But often I work with others from Institute of Global Sustainability, or from folks from CDS and from Hariri and others. So sometimes what you want to do, as Mark was saying, is so complex that you need to even reach beyond the specific interdisciplinary center you are in.
So, and I see the QR code is up, so please do enter your questions. So all of you talked about the access to and interaction with faculty from all these different disciplines. I'm sure you need PhDs from all these disciplines, but none of you have any control over what faculty or PhDs show up to Boston University. So what do you think are the challenges about how the institution can make sure you get the right faculty and students? And I'll start with Elise on this one, because you're, at least in engineering, all the faculty have to go through you before they get hired. And all the
Yeah, right. So I mean, the faculty are part of the lifeblood of the university, and really, the faculty we hire. Before this event, Ken and I were talking about, we think, two major, multi-million dollar grants that are coming our way from engineering faculty, and we think, these were such extraordinarily positive, consequential hiring decisions, we made, years ago, right? So hiring faculty is such a major investment that universities are making, not just on behalf of themselves, but really on behalf of society. So that's one thing. And then the other is, really thinking about who are the faculty who are really going to thrive in the culture that we have of working in this with porous boundaries between disciplines, working together, being willing to engage in these conversations where it might not be benefiting your own research, but your expertise at that moment, but your own expertise is benefiting somebody else's research, right? So that culture is really important. So it's not just the quality of the scientists and the engineers that we're evaluating as candidates to hire, it's also about their interest in participating in this broader culture of convergence. And the final thing I'll say is that conversations about what areas we want to invest in via faculty hiring, those aren't decisions that I make myself, or they're not even decisions I make with my own leadership team of department chairs and associate deans. They're also conversations that we have with center directors and other faculty about what are they seeing on the horizon, what are they seeing as the emerging needs, and the really cool stuff that's going to make an impact, even if it's 20 years down the road, but it's going to be of such a scale of impact that we can't ignore it now.
Do the other panelists want to talk about the role they think you should play as center directors in recruiting the right faculty and PhD students? How does that work?
Sure, just maybe a few words. In addition to my center director role, I led some Convergent faculty searches. And I think one thing that's also interesting is that you may not necessarily know what's going to be the toughest problem in a few years. So you recruit people who are able to do convergent research, and faculty evolve as well. So, I mean, maybe, I don't suddenly reinvent myself into being a biologist. That would be tough. But, faculty, their research, their expertise does evolve quite a bit. So, again, when you look back, I wasn't doing anything about data centers as part of my PhD. I was working on energy efficiency. And now, I'm heavily working on data centers. So similarly, depending on the problem, how they are emerging, these faculty we hire, we look for people who are able to collaborate across disciplinary boundaries, who are able to evolve their expertise and learn and build new incentives, essentially. And that's been really fantastic to see at BU over here.
My hypothesis is if you create a convergent culture for research across the institution, not just research centers, you'll end up attracting a much more intellectually fearless set of faculty because there's so many different people to interact with. They can take on any challenge they're interested in, not just the one they're personally trained to. And likewise with PhD students, I would think, yes, they're coming to get a PhD in a discipline, but what they really want to do is impact society. So, okay, we do have some questions here. I have to get this one out of the way right away. It's for Nahid. With the FIFA World Cup bringing people from all over the world, should we be worried about disease spread? And how can your center help?
Yes. So the answer is yes, but not the diseases you think. I'm sure all of you guys are wondering, do I need to worry about hantavirus and Ebola? You do not. For many reasons I can go into, once we have some refreshments. But what we're doing is multifold. So Beacon, the program that I talked about that's at my center, has already been doing mass gathering reporting. So for Olympics, for example, we reported, I was just talking to somebody before the event, we did a preliminary assessment of like what's circulating in the area. We used our globally based outbreak analysts, particularly those that are based in Europe and those that are based in some of the places where people from teams from Olympics are coming from, to provide a preliminary assessment of like what we think is circulating, what could happen. In general, many of the mass gatherings, you see the same kind of issues. You see vaccine preventable diseases. Measles the rates are up. You see things like meningitis, again, another vaccine preventable disease in some cases. You see diarrheal diseases, respiratory diseases, and sexually transmitted diseases. Those go everywhere mass gatherings go. And that's what we predict is probably going to happen more so than any of the other diseases you're hearing about. One last thing, speaking of convergence, that we're probably going to see are going to be vector-borne diseases. So on Beacon last year, we reported this outbreak of chikungunya. It's a viral infection that's transmitted by mosquitoes. So the reason you may have heard about it is that we have those mosquitoes here in the US. The reason we don't have a lot of cases is because we don't have a lot of virus, thankfully. But in this year alone, what we've noticed is that there's local transmission in in New York State as well as in Florida. That means if there was more virus in this country, the mosquitoes are ready. They're going to bite one person and then infect another one carrying that virus. Imagine people from all over the world coming, including from places where there's chikungunya and dengue and all the other vector-borne diseases all gathering together, getting all the summer mosquitoes biting them and then biting you. So it's actually those diseases we worry about more than hantavirus and Ebola. And that's how Beacon's going to help. You can check it out. We're going to do daily assessments on World Cup. So if you're worried about something, we're going to do assessments of all the FIFA sites, and you can check it out on beaconbio.org.
Okay, I'm feeling much better now. Plus a lot of spray. Okay, this is for two faculty that have had startups. Can you speak a little bit to how startups in the audience might engage with BU faculty? And the inverse a bit, how does BU support you creating startups. So Mark, you want to start us off?
Sure. So BU is first, BU is very supportive of startups. They support the idea of taking the technology that gets developed here and moving it out. And they do that through many ways. Everything from thinking about the IP, as well as making introductions to individuals who might be interested in, coming on board and being part of the company. Likewise, as a small startup, you're always interested about, collecting as much data as possible and working with a number of people out there to try to build your network. And so companies here, like myself, Keelicon, we'd be very open to working with people to understand what their needs are, to see if our technology matches. If it matches, great. If it doesn't, then we can refer you to another company. So it goes both ways. And we've had examples of all of that here at BU, where companies got started and they're interacting with another small company or a large company out there in Boston, and likewise an established company in Boston actually working very closely with the startup here. So both ways, it's all good.
Great.
So maybe to reiterate on some of the things that Mark already mentioned, BU has mechanisms to support startups that are coming out, including an award called the Ignition Award, for instance, that provides some funding, especially when you are going from the research stage to, there's a big gap between early stage research and product. So you need mechanisms to fill in that gap by doing more work. Maybe you want to do some prototypes. Maybe you want to, do some customer discovery, et cetera. And federal agencies have some programs too. But even before that, BU provides some support and an ecosystem, like Mark mentioned, so that you can work on these. For startups in the audience, how to engage with BU, we have a large engineering school with many areas that were mentioned here today. And we have very eager faculty and PhD students to engage with external partners. This could be in the form of internships. This could be in the form of, collaboration discussions. This could be in the form of funded projects. So we are doing this all the time at the College of Engineering. So if you are interested, let me know. If you don't know who to contact, I'm also the Associate Dean for Research currently. So if you let me know, I'll connect you to the right faculty members in the area that you're interested in.
Great. Two more questions that I like. One is, I've made the executive decision is for me. Does the spirit of interdisciplinary work at BU extend beyond the hard sciences? Do you work to the liberal arts departments, for example? And the answer is absolutely. If you remember the 8 areas that Costa described, health along the lifespan, a lot of it discussed here. Infectious disease and the immune system, a lot discussed here. But another one is AI, computing and data science, a lot discussed here. But another one was global sustainability. We're talking about every aspect of this challenge, from the technology of renewables and carbon storage and so forth, and battery and energy storage, but to the business and economics of the grid, to public policy, which drives a lot of the innovation or not in terms of the way communities functions and companies functions and business models that drive these things forward, all coming together at the earliest possible stage, including mis and disinformation, earliest possible to make sure whatever innovation you're thinking of has the highest probability of succeeding, and as opposed to something that's incredibly creative and can't succeed because you didn't include the other dimensions of the problem early on. The same with urban sustainability and urban resilience and urban function, which depends on culture, the humanities, and sensors, and traffic, everything you can think of, healthcare delivery, mental health, and so forth, public policy, and so on. Even robotics. With the advent of AI, what is human anymore? What are the humanities in the age of human-like robotics? So yes, the answer is convergence is everywhere and all those themes. The next question, I'll pivot to the committee again, but starting with Elise and other ones. The question is, how is convergence reflected in undergraduate or graduate programs? I'll expand the question a little more provocatively is, should we get rid of departments and majors associated with traditional disciplines?
Okay, so I'll start with the first part first. So how is convergence? How does it manifested for education, right? For our undergraduate students and our graduate students. I mean, certainly, although I just said education, certainly manifests in research opportunities that our students have. We have a very strong culture of undergraduate research, and in the College of Engineering, about 40% of our students participate in undergraduate research. That's really high compared to the national average. And then we have very robust PhD programs, and a lot of our master's students get exposed or deeply participate in research as well. But in terms of education, so I argue that engineering is a form of liberal arts, right? So it's really about drawing information from a lot of different disciplines, right, in order to make kind of make new insights, right? And so engineering draws on knowledge in the natural sciences, physical sciences, and even policy and social sciences. And so I feel strongly that a broad education, particularly for our core curriculum that stretches across all of our engineering majors, is one way in which we are seeding the future success for convergent thinking in our students. Okay? So they're not just coming in right away and doing, say, only mechanical engineering, right? That they have through the core curriculum, through the general education requirements, they really are exposed more broadly. So that's one. Another is through project-based learning, where anyone who's been involved in any sort of project, particularly one that doesn't have a defined answer, you realize really quickly that project is not just about skills in one particular domain. You really have to pull together the whole kitchen sink, right, and consult broadly. And so we do have very substantive projects for our students beginning in the first year and culminating in the senior capstone experience, which is basically a year-long, joyful experience, shall we say. Stressful for the students at times, but they come out with, this is a working prototype, right? You start from a maybe poorly defined question or need that a customer has. You then say, okay, what are actually the design specifications? What's going to meet those needs? And you ultimately work towards a functioning prototype. And so that is really requires a lot of skills in convergence.
Anything else? So I got a sign about 5 minutes ago that we only have 2 minutes left. So we'll wrap it up here. There's a lot of great questions here. I'm sure the panelists will be happy to stay around and mingle and talk, and please come up to them with their questions if you're the one who asked it. I think they're terrific. And I just want to thank all of our panelists and the audience for coming tonight on a Friday night. I'm really, really impressed. So thank you, everybody.
There's another QR code now up here. So I want to thank Oracle, our corporate sponsor this week for Tech Week, and everyone that made this event possible. What makes gatherings like this special isn't just the ideas that are shared on the stage, but the relationships that are built in the room. So please join us for the reception. Boston is having a moment right now, and more importantly, we're building a movement. So please scan the QR code. Tell us a little bit about yourself, how you're interested in maybe engaging or partnering with Boston University, because we are open for business. We're open for partnerships, for research collaboration, for entrepreneurship, for industry engagement. We're open to have conversations with anybody that's interested in shaping the future responsibly and boldly. So thank you for being here tonight. I don't want to keep you between some libations and refreshments. Have a good evening. Thank you.